This is Rough Science, coming to you from the Spice Island of Zanzibar off the east coast of Africa. Our scientists face their toughest trial yet as they take on the ocean. They have to complete a set of marine challenges with a few simple tools, some basic bits of kit, and a boatload of ingenuity. Our base on the Indian Ocean is a traditional fishing dhow, and our site on land is an isolated beachside workshop. It's destination paradise for rough science. Our 4 scientists are Kathy Sykes, a resourceful physicist with boundless energy. Yes! Mike Bullivant, an imaginative chemist who embraces the near impossible.
Oh my word!
Ellen Macaulay, a fearless have-a-go botanist from Missouri.
Next thing is rinse it.
Jonathan Hare, physicist, inspired inventor and artistic engineer. And me, Kate Humble, an experienced diver. I'll be going underwater to put their inventions to the ultimate test. Together we are Rough Science. Now we've had a look at Zanzibar's beautiful underwater world, but what we haven't done yet is had a listen to it. Now I know that sounds absolutely mad, but it's quite noisy down there and they're wonderful sounds. So, Jonathan and Mike, do you think you could come up with some sort of ingenious device that would allow us all to hear a bit of fish talk, a bit of conversation on the reef? So if you can get on with that, and Kathy, in the meantime, could you come up with some sort of way of spying on what we're listening to? Something to be able to peek beneath the waves and see what's doing the talking. Okay. Yeah, that would be great. And Ellen, as we know, seeing and hearing mosquitoes is never a problem.
I can do that.
So do you think you could come up with some sort of repellent so that we don't have to sit in the middle of the night listening to... Should be great.
I will give it a whirl.
Okay, well, you have 3 days, everything in the workshop as usual, anything that you can find around here, and the ever-faithful magic trunk. This week, the scientists are going to get to know Zanzibar's wildlife a little better. Kathy, Jonathan and Mike have to find a way of seeing and hearing what's happening down on the reef, and Ellen's task is to keep us all a mosquito-free zone. Since it's me who's going to be testing her repellent, I've got a vested interest in making sure it works.
And, oh, God.
Well, that's for me,
You've
so I
been
can get
kept
back to
awake.
sleep.
You've been kept awake by those mozzies.
Fortunately, Ellen already has some ideas about how to make her mosquito repellent. But that's not the hard part. It's devising a scientific method for testing it that's going to be tough.
Here we go. This is what we're looking for. To prove to Kate that I can make mosquito repellent, I've got to have some mosquitoes to test it on. So I'm collecting the larva and the pupa of the mosquito, which is the easiest way to get them, and then I'll grow them up. Then I can put them in a cage, and Kate can put one arm in with mosquito repellent and one arm in without. And if I do it right, only one arm will get bitten.
But whilst Ellen has clear, if somewhat alarming plans for her challenge, Jonathan and Mike haven't even left the beach yet.
You have set us a really difficult one this time.
Oh, don't waggle your finger at me. What? Well, OK, if you want to hear what's going on underwater, where do you start?
We're trying to make a microphone, really, that will work underwater.
Yeah.
So it's got to be waterproofed.
Yeah. How do microphones work, actually? I mean, how do we hear sound?
So something makes a noise, it creates little pressure waves in the air.
Yeah.
And that travels through the air to your ear, and then obviously there's stuff in your ear which then cuts that so your brain can hear it. Now, a microphone basically is sort of super ear. It's something that converts sound into electricity. So once you've done that, then you can put it through the electronics and amplify it loads of times so that you can hear everything that's going on.
What's the next stage? We need to do more
start
thinking.
work.
And we've got to think up some way of making that sensitive thing which will convert the sound into electricity.
But we've got a lot more thinking to do before we actually start.
I'm getting the hint. Shall I clear off then? I'll leave you in peace.
Subtle.
Good luck.
Is there a chemical way you can do it?
I'll rack my brain. I'll rack my brain.
Meanwhile, Kathy's found herself a load of old drain pipes and a design for a sort of underwater periscope.
I could just kind of put it straight down into the water to have a look, but I think it might be better to have a right angle in it. Then I'll be able to look down and rotate it, and so see 360 degrees around.
If only it were that simple.
Oh, none of them set.
What are these wriggly things?
Mosquitoes have laid their eggs in the water that I collected from today.
Yeah.
They've developed into these larvae and then into the pupa, which are the little comma-shaped ones.
Okay.
What we're trying to do is make a repellent and prove that it works.
Okay.
To do that, I have to have adult mosquitoes.
Yeah.
But there's a catch. Mosquitoes that are just flying around here, they could potentially be carrying diseases. And if we do a test on your arm and one of those mosquitoes bites you, you could get sick. And so in the next day or so, I am looking for the adult mosquitoes to come out of the pupa, and I'm going to catch them all. There's no way that these mosquitoes will have any disease because I've raised them. They haven't had a chance to bite anybody.
So the first person they get to bite is me.
Exactly.
Well, they may be free of blood-borne diseases, but I'm still not looking forward to them feasting on me. Meanwhile, Mike and Jonathan have come up with an idea for their underwater microphone. Mike has found a chemical solution to their biggest challenge.
What are you up to?
I'm making the key component of the hydrophone, or the microphone.
What, out of that lot?
Yeah. I'm making piezoelectric crystals.
What's a piezoelectric crystal?
It's a crystal that when you apply a slight strain to it,
Yeah.
it will produce a voltage.
Right.
Even the slightest strain, like a sound wave.
So the sound wave hitting it will produce the voltage, and that's what you need to
The
make
rest
a
of
microphone.
Jonathan's circuitry will do the rest.
So what's all this bit then?
Well, I can make this crystal from cream of tartar, which I've just put in this water.
Yeah.
And I add some washing soda. Now, those two chemicals will react and produce a chemical called Rochelle salt. And if I boil this up, filter it, leave it overnight, and from that solution will grow piezoelectric crystals of Rochelle salt.
So Mike's on a quest to grow a very special crystal, and Jonathan is getting to work on the electronics end of their underwater microphone or hydrophone. He's planning to use some bits and pieces from a couple of vintage radios to amplify the signal from Mike's crystal.
OK, so I've got this old circuit board out of the radio, and I've wired it up to the speaker, which I got out of the other radio. So I'm just going to wire this up now to see if it does anything. Not a lot. It's doing something, you can hear it click. When I turn the power on and off, you can hear a click in the speaker. What I wanted to hear is see if there's any hiss. If it was hissing, it would mean that the circuit was working. At least it's going click.
Not great news for the hydrophone team. They won't be able to hear anything unless Jonathan can get the amplifier to work. For everyone, it's just one of those afternoons. Ellen's struggling to turn some old coat hangers into a mosquito cage, and Kathy's still battling with her drain pipes.
So it's fit in one place in the pipe, and now it doesn't fit anywhere else. Marvellous.
But one net curtain and some careful soldering later, things are beginning to look up.
I'm very, very happy with that, because the fact you can hear it hiss means the amplifier's working, which is great. So if we do get a signal from a hydrophone, at least I know we're going to be able to hear it through the loudspeaker now, which is great news.
The big question is, will they have a signal to amplify? The hydrophone won't work without a crystal, so it's all down to Mike, the master crystal grower.
It's very hit and miss. I don't know what's the best concentration to grow a crystal of Rochelle salt. So I'm doing it at different concentrations. I'm going to leave these in different places overnight, some in warm places, some in cold places. And the crystals will just grow overnight, I hope. So these 6 different concentrated solutions of Rochelle salt in water represent our only chance to produce a crystal for Jonathan and my hydrophone. We've got to get a crystal by tomorrow morning, otherwise the hydrophone just won't work. We'll have failed.
It's the end of day 1, and Kathy's also worried about her periscope. She sealed one end with Perspex to make it watertight, but her real challenge is still to come. She's got to find a way of reflecting light around the bend in the drain pipe.
I've been playing around with a little bit of glass in here.
OK.
To provide a nice reflection. It really needs to be a mirror.
I was going to say, I thought periscopes all worked on mirrors and reflection.
Yes, I mean, the glass by itself isn't a bad reflector,
Yeah.
but I really need to have a mirror there, so that's what I need to do. Got to make a mirror, and I think that's the hard bit.
It's the morning of day 2 and the moment of truth for Mike. 5 of his jars of solution have failed to produce any crystals. So what about jar 6?
Look at this beauty. Oh, we've got a crystal.
Oh, well done.
We've got
That
more
is
than one
brilliant.
crystal, in fact. We can split those up, can't we, Jay?
Yeah.
I mean, is that going to be enough?
Yeah, that's probably enough for 4.
4 hydrophones?
Yeah.
Really?
So I can try different
we just
things.
want the one.
Let's get on with the hydrophone.
And do your hydrophone. Good on you, guys.
Of course, it's still got to work.
Over in the workshop, Ellen is keen to show me her own new arrivals.
Look in there.
Yeah?
See those mosquitoes on top?
Yeah.
They've just emerged from the pupa.
Wow.
They're drying their wings and they're waiting to fly and join the rest of these adults that have come out.
Have these all hatched overnight?
Yeah, they're all adult mosquitoes. And they're just waiting to feed on your blood.
Oh, good, thank you.
And actually, it's only the females that will be biting you this evening
Yeah.
because the females need a blood meal with protein
Right.
in order to lay eggs.
Okay.
The males only feed on plant nectar.
So, if I'm lucky, these will all be males?
No, they can't be.
I might just swat you.
Mike may have finished his hydrophone duties, but the scientist's challenge was to find a way of seeing as well as hearing what's going on underwater. Now Kathy needs his help with her periscope. She wants to coat her piece of glass with silver to create a mirror, and that's going to take some tricky chemistry.
You've just got to get the reaction started.
The first step is to make nitric acid. Mike's boiling up the ingredients in a flask. If all goes to plan, fumes of nitric acid will pass into the second bottle.
I'm pouring cold water over here to provide a cold surface, and the nitric acid vapour will pass into this bottle and condense on the inside. That's nitric acid.
Once he's got the nitric acid, Mike can use it to make silver nitrate, one of the key chemicals used to silver mirrors.
So, Kathy, you want some silver nitrate?
I do, desperately.
That's a silver earring, right? It's the Lord of the Rings trick. This is the nitric acid that I made, and the acid will dissolve the earring and form silver nitrate, because that's a silver earring.
And it's as easy as that?
I'll put it on the fire, just to speed the things up. So let's just stand back from it.
That's really poisonous stuff, isn't it?
Meanwhile, Ellen is making final preparations for this evening's mosquito repellent test.
This should keep them safe until they're ready to feed. Hope you're hungry, girls.
Now Ellen has to start work on her repellent, and it's crunch time for the hydrophone. Rather than cut up the big crystal, Jonathan has decided to experiment on one of the smaller ones in the bottom of the jar. If the crystals don't work, it's back to the drawing board.
I'm just going to wire the crystal straight into the amplifier. And in principle, if I just tap this, we should be able to hear it's acting like a microphone. So turn the amplifier on. Every time I tap the crystal, you can actually hear it coming through the loudspeaker now. So just by tapping the crystal and putting pressure on the crystal, that's producing a little voltage by this piezoelectric effect. And that voltage has been picked up by the wires going into the amplifier, and you can actually hear it coming out the speaker. So if the crystal wasn't piezoelectric, when I tapped it like this, you wouldn't hear anything out the speaker. So effectively, it would just be like that. So is this working? Which means we've got the heart of our hydrophone, which is just brilliant news.
Mike's crystals may be working, but he's not having as much luck with his new challenge. The other key chemical Kathy needs to silver her periscope mirror is ammonia.
How's it going, Mike? Any ammonia?
Oh, desperation stakes, baby, desperation. We haven't got the ammonia, but what I've done, I've got cleaning products, and some of those contain ammonia. And all I'm doing at the moment is putting some in a test tube like that, heating it up, and if there's ammonia in there, it should boil off. That splint is soaked in dilute hydrochloric acid, it will react with any ammonia vapour that's given off and form white fumes. This is a window cleaner. No, see, there's no white fumes. You'd really be able to notice
You'd be able to see them.
Yeah. So that product's no good. So I'll go on to the others. You'll hear a squeal of delight if I find it.
If you find
Don't
anything.
worry.
Hey, well, thank you for trying, but with no ammonia, right, I can't make a mirror.
I think it's going to be very difficult.
Mike's only got a few more cleaning products to go.
So it's not that one.
And he looks like he's running out of options.
Any joy?
I think that's ammonium chloride. It looks like steam, but I'm not sure. It could be steam. But let's not despair.
Do we have any other options if there isn't any in the cleaning product?
I think you can make ammonia from urea, and there's urea in urine.
So we can all pee?
If we all pee into the same bucket and boil it down, they might get their best jobs on rough science.
So the fate of Kathy's mirror is resting on Mike's unpleasant Plan P. Meanwhile, Ellen is out collecting some natural ingredients of her own.
The reason I think lemongrass is going to be a good mosquito repellent, is because it smells really strong. And mosquitoes are attracted to body odor as well as CO2 that we exhale and are released from our body. So if I have something that smells really strong and that mosquitoes don't find attractive, hopefully it'll keep them away.
Back at base, the rest of the team are making their own contribution to Mike and Kathy's ammonia production line. And Ellen has nearly finished her repellent.
I've just ground up the lemongrass in alcohol, and the lemongrass oils should dissolve in the alcohol very, very well. And then I'll just let it sit for a couple hours, and by then, it should work really well as a repellent.
Jonathan is also making good progress with the hydrophone. He's using a tin of tomatoes as a platform for the crystal. And things are looking up for Kathy and her mirror. Mike has finally conquered the ammonia crisis.
So this is the team's urine reduced down. It's about 3/4 of a bucket full of urine. Put it over the fire, and this is what you end up with when you reduce it down. Need to add to the urine potash. And this is just ashes from the wood fire here, which I've boiled in water. And we mix these two chemicals together, and what we should produce is ammonia gas. So let's just let nature take its course. And I'm confident that we'll end up with a solution of ammonia in water.
It's dusk on day 2, and at last Kathy has all the chemicals she needs to silver her periscope mirror. The end is in sight for her underwater viewing contraption. But despite Mike's success, I'm not feeling in the best of spirits. Those mosquitoes are hungry.
Can I confess that I haven't really been looking forward to this moment terribly much? Do you have repellent?
I do. Lemongrass mosquito repellent.
Okay.
And it's made up of the volatile oils of the lemongrass. And so it basically repels mosquitoes. They don't like the smell. Otherwise, they can sense you from about 50 meters away and they come toward you.
So hopefully now they come near me, will they, and then go, oh, I don't like that smell.
Exactly.
I do. It's lovely, isn't it? Okay, so...
Also makes it
and
really
this
nice
arm we're
to-
leaving bare.
Yes.
Right then, let's try this. So this is the non-repelled arm.
Yep, and let's just kind of wake them up. It's not quite time for them to feed.
That's fine with me. And this
gosh,
is the
how
repelled arm now going in. Oh, there's a mozzie possibly looking interested on the repelled arm, but it's not landing.
But these should actually bite you.
They don't look that interested. How long do I have to sit like this?
The later it gets toward dusk, the
Yeah.
better. So it might be a half an hour, an hour.
Well, I've got some mirrors to do. You wouldn't excuse me, would you?
Absolutely.
I've got some chemistry.
Yeah, I've got to do my hydrophone.
You can't just do that and leave me.
It's okay.
And then, just as I'm starting to relax...
Ellen, come and rescue me!
That's great, Kate.
No, it's not! Okay, the repellent really is working. It's working.
This is a scientific experiment.
Yes, it is, and it's worked. It's been brilliant.
Okay, look, there's another one.
Ow! It's got teeth, I promise.
It's all for science, Kate. Look, the mosquito repellent arm.
Yes!
Nothing's getting near it.
With 3 attacks on my bare arm and none on the other, I'm satisfied that Ellen's repellent works. From now on, none of us need fear the mosquitoes. Day 3 and the team have only one morning left to complete their challenges. This afternoon we set sail for the reef, where we'll find out if their inventions really will allow us to watch and listen to the world beneath the waves.
This is all looking ready to go.
Yeah, it's exciting. Well, I've used an old tin can here.
Yeah.
And mounted Mike's crystal right on the end there. And when the sound goes in here, it will make the end of the can vibrate, which squeezes and lets go of the crystal just a little bit. And that change in pressure produces a voltage from the crystal, which is directly corresponding to the sound.
Okay.
At the moment now, you can hear 1, 2, 3, there's nothing happening.
No.
Because I haven't actually wired the crystal up to this is the final bit.
Okay.
So it's going to make a hum because it's right on the amplifier. It didn't do anything a minute ago,
No.
right? Now I've wired the crystal up. It's the only difference. 1, 2, 3, 4,
That's
5.
amazing.
It is amazing. It's even feedback.
Can I try?
Hello. It works.
Incredible.
It's really, really sensitive. Mike's crystals are brilliant.
Jonathan may be pleased with himself, but in Mike's lab, Kathy has a difficult morning ahead of her. Chemical silvering is a tricky process, and getting the exact proportions of each chemical is crucial. One drop too many, and it'll all end in disaster. She's decided to experiment first in a test tube.
Fundamentally, what's going on is that I've got silver nitrate, which means I've kind of got silver ions kicking around in here, and silver ions are just silver atoms with a couple of electrons lost. And what I want to do is have them just ready to crystallise, so just ready to turn back into silver atoms. And what I've got to do is just mix up these different chemicals so that they're holding the silver ions ready to turn into silver metal. And the idea is to cover the whole test tube with a very thin layer of silver, in fact, just kind of a few atoms thick. And what that ought to do is make it go really shiny, like a mirror. If you were doing this back home in a chemistry lab, then I would be reasonably confident about getting a mirror. I'm really, really suspicious about having to make the ingredients out of urine and stuff from the fire and earrings. It's just not the same thing.
All Kathy can do now is keep on shaking. Meanwhile, Jonathan is hard at work putting the finishing touches to his hydrophone. He's sealing the delicate crystal and the electronics inside a waterproof housing.
Yes! It worked! I don't believe it!
Silver mirror. Isn't it astonishing?
It is a silver, and it's just gone from black.
Yeah.
A gungy black solution, and me standing there all pessimistic, and it's turned into a mirror! Yeah. Look at that! Oh my God, I don't believe it.
Kathy may be celebrating, but there's only an hour left before we leave, and Jonathan still has to test his underwater microphone underwater.
I've got a little alarm clock here, which I'm going to set off, and then I'm going to dunk this in the water, and then I'm going to listen to it with the microphone, see what it sounds like. OK. 1, 2, 1, 2. It is working.
Thanks to the failure of his alarm clock, Jonathan can't tell whether the hydrophone is working underwater or not.
But I guess alarm clocks aren't really meant to be doing this. One more try. Stop it. Well, I wouldn't say that's the most definitive scientific experiment. Oh, no, I don't like the way it goes. Doesn't sound good. Let's turn it off and open it up. Oh, no. It's full of water. We've definitely got a leak. We've got to sort that out, otherwise we're not going to be able to do anything. Oh, no. No, the crystal's broken as well. It's fixable, but it's going to take time.
Kathy is also up against it. Now she's got to start silvering all over again, this time with the glass for the periscope.
Well, I'm just greasing one side of the glass so that I only get mirror deposited on the other side. That's the idea. And I've got the solution as ready as I think I'm ever going to have it. I'm still not very confident about it. It's just such big quantities, it's hard to handle, really. And even the bucket I'm using is the one that everybody peed into, so it was hardly the cleanest thing we had.
For Jonathan, it's a race against time to fix his hydrophone and redo the waterproofing.
How's the crystal?
Well, it's pretty manky. It's broken, but I think it's still going to work. But I'm just being optimistic.
He won't have time to test it again before we have to leave for the reef.
Oh! OK. Oh, my God. It is mirroring. Ooh. So, I need to dry it out and put it in the periscope.
Kathy's finished just in time. But Jonathan is still making last-minute tweaks to the hydrophone as we all set sail. Fumba, on the west coast of the island, is home to a protected marine reserve with some of the best coral reefs in the area.
Right then, well, we're here. It's a beautiful spot. What's it going to look like underwater, Kathy?
I think we need to have a look. But first, just to check that it's all working on land.
Yeah.
I can see a rather splendid island over there.
Well, that's a good start.
A good start.
See what's down there. Now, the most obvious thing to me at the moment is, aren't you looking down the wrong end?
Well, Kate, I just found that it worked better this end. It was, ooh.
I like those oohs. What's going on?
Oh, I can see some coral. It's a rather small view.
Oh, look at that. Wow. And there are little fish down there.
Little fish?
Yes.
Let's have
I
a
think
look.
this might be a hydrophone moment. What do you think, Jonathan?
Let's try it.
Shall we try it?
I'll just turn it on.
Oh, fantastic.
I know it's working because you can hear it. But I can't hear any fishes or anything.
No, it looks fantastic, Jonathan. I have to say.
Can you see it?
Yes.
Well, the good news is no water coming in, I can tell that. I can't hear any fish.
But the fish
They've
clearly
gone
know they're
quiet.
being spied on.
They don't want
And
to
they've
say
all
anything.
gone, we're not talking.
Wait a minute, can you hear that? Little clicks.
Oh, yes.
Oh, yes.
Oh, yes, it is.
This might be a little bit directional. Let's just turn it round.
That's definitely something.
Little nibbles.
So there you are, the sounds from the reef transmitted to us on the surface via a crystal and a tin of tomatoes.
Well, a wonderful marriage, I thought, this week between chemistry and physics. And, of course, the repellent's clearly still working because there are no mosquitoes here. So congratulations to all of you. Well done. Well done. And join us next time for more Rough Science.
Next week, the team build a lighthouse on an uninhabited island. For a free magazine about all Open University programmes, call 0870 900 9581 or go to open2.net, where you'll also find more about this week's challenges.